Where's your 5 volts coming from? Is that
5 volts coming from this guy and the linear regulator here.
okay?
Okay, just move this stuff out of the way here. Make sure nothing's going to short out. PWM is going to be second. If I just go underneath it. There we go. Okay, so PWM is the centerpiece. You can see why I like having printed circuit boards because it's
Let's move the thruster
quite nice.
before you get things running.
Okay. The direction's plugged in. Good. PWM's plugged in. Motor output's connected. Excellent. Okay. Power, good. Nothing looks like we're touching at all. Power to the heat drive. the digital isolator. Looks fine. Let's begin to power it up. First tap.
T-1. No.
Oh, turned on. See that? See what happened? I don't have that battery plugged in. I forgot to plug that in. And all of a sudden the motor kicks on.
Yeah.
That's one thing I need to figure out.
Do we want to change that or?
Good question. Don't really know exactly how. I probably need to. I have a pull down on the PWM pin to the 24 volt system, but even that didn't do that. So I think the isolated the digital isolator is somehow giving a little bit of current. Because the other pins on the other side are probably floating.
Yeah.
And it might see that and go on. That's a possibility. Now that we have it powered on this isolated side, we should now have the motor not turn on. So we'll put this on, and here we go. I'm going to start it. I will now increase the speed.
There it is.
Yep.
So now the key thing is we're going to keep it running. Is it going to overheat? Is it going to, according to my calculations, it should survive. We'll see.
Shouldn't.
And we're testing with no ramping up or down, so this is worst case.
You want me? We can do a full bore if you want to.
Whatever you think the board can handle.
I don't know. We'll find out. That's maxed out right there.
It's 100% duty
Yep,
cycle?
100%.
Alright. Let's get this thing in the water because the motor doesn't cool itself unless it's in the water. So.
Right. I'll turn it all the way down.
Yeah.
Okay, so yeah, you gotta be careful. Don't
I'm sorry.
Yeah, don't let that go in the water.
Not letting it go in the water.
Okay. Yeah, be careful that these don't touch either. Otherwise we'll just short the motor and that'll be fun. Okay, so, ready?
Ready.
Here we go.
And we're in reverse.
Oh, reverse?
Yeah, we're reverse.
Switch direction.
Well, yep.
Pretty cool, huh?
Nice.
Yeah, that's what I'm talking
That's
about.
very cool.
I'll analyze the MOSFETs here. Whatever we're going to call it, analyzing.
You should push some decent amount of water.
Yeah, I mean, if he
I don't
turns
even
it
have
up,
it maxed up. Here we go, let's do a max.
yeah, I gotta hold it still.
Yeah.
Our other thrusters, I could hold still all day. Like they weren't really giving as much thrust.
The MOSFETs are barely warm. Linear regulator is starting to put out some little bit of heat, but not too bad. It's completely acceptable. So I mean, I could ramp it up a little more here.
And the linear regulator doesn't matter what the thruster
That is
speed
max speed right there. That's max.
Yeah, we're moving.
All right.
Wow.
turn it down.
We're booking pretty good.
That is good.
Okay, I'm
Well,
examining
I'm
the
starting to feel a
MOSFETs
little
some
better
more.
how much money you spent on this.
Yeah.
Everything seems fine. The TVS dials are doing okay. Let me see.
I can get a reel for you so you don't have to put your hand in the water.
Because this stuff's cold.
Okay, I just want to run in here and see how the TVS dials are doing.
Okay, just watch.
Do you want me to hold it?
It's okay. Turn it sideways.
No, you can keep.
Okay, I'll turn it down here. I'll just turn it off. You can move your hand in position wherever you want.
It's not gonna fit.
So the one thing I am
I was
noticing...
thinking you can do this right here.
So far, the one thing I'm noticing that actually is getting the hottest